Hello everyone. Today I'm going to show you how to design a connection which you already designed a building, a steel structure, and you're going to design a joint connection. I'm going to use IDEA StatiCa connection design software, and the properties or the connection joint will take from the SAP2000. Uh, IDEA StatiCa has ability to import the joint specific joint from SAP software, but unfortunately my SAP is 2000 version 22, which is IDEA StatiCa cannot support until 20. Uh, in this case, I'm going to select a joint, and just take the loads internal loads, and then do the design. For this, I'm going to frame using this is seismic. I'm going to use load 3, which is a combination of earthquake load, dead load, and live load. Now let's see, here is a joint, or any joint you wish, but make it something simple. And to now let's see, we are going to design this joint, so this joint has one beam here, and one beam here, one here, one here. So the first we are going to find such a connection in the class of the structure. First, let's see here, we have first class, and then go to the which structure has one column beam, was called moment resisting shape. Here is from topology, we select this one because we are going to use some combination nut bolts or hinge properties. So I'm going to select this. Here is the steel grade. First of all, I'm going to use American codes, and the weld should be here, the bolt assembly. We also can change this later, and the steel grade should be, we can change later. So create, the next thing is from this point we should take the force, which is Kip's foot. I'm going to take the actual force. The actual force is so very small, about 0. The actual force is 0.658 kips, and this is uniform, and the torsion is, so we are not going to use this torsion, and we are going to check the maximum shear force in the end of this. So it's about minus, a moment is minus 32.8 kips foot, and the shear is about 12 kips. uh, so this beam is same with this beam, which has here is moment. No, it's not same, so we have to give this is moment 2. We are going to use moment 3 here. Yes, the moment is a little less. I'm going to use this is 23.8, and the shear force is 10 kips foot, and the moment is minus 30.23. So now we have these two, moment and shear, and axial forces. So axial force is very small, we can ignore, or even we can add this. The second is we took these two, 1, 2, and the second we're going to take the column. The column is in the end. We have axial force about 85. We can use 85 minus 85 kips, and we can take this moment, which is 78 kips foot, and the shear force is about 12 kips. Okay, then the lower part is also axial force is 129 kips, and for moment is a little smaller, which is 53.39, and the shear force is about shear force is about 30.75. Okay, that's done. 130. Okay, now we have, and the next is we are going to check the element. Which element is this? Which cross section is this? For this reason, I'm going to here going to section, frame section, to apply. Here we can see this is W, this is W, this is W, W12 by 35, and the column is 10 by 112, 10 by 112. So here we are in an IDEA StatiCa. The first thing is we are going to change our column. This is our cross section, beam 1. We're going to edit the parameters using the another steel material that was a grade B FY. This was our steel, and the shape is we are going to select W shape. This is W. We used, I think we used metric. One thing is where I should change the the unit which is very important. This is I'm going to back again, new, go to the unit. Here is unit. I'm going to use type of unit, imperial. So I'm going to use imperial. Okay. Yeah, this is imperial into back to here. Now it's changed. Good. We are going to select beam, edit. The first we are going to add grid 50. Still, this is which is FY30. This is it. Okay. And the second is going to select W shape, and the shape should be, that's about one is 100 should be, and 12 should be 120. Yes, this is all. We can come here and W shape using ACI code. One is, this is beam is 12 by 35, 12 by 35. This is 12, this is 35. Okay, so this is what we have. Okay, and the second, here we can apply W by 35, and the column should be 10 by 112. We go add again. Sorry, we go to edit. We're going to edit and using grid 50 and adding and this is 40 here and 10. This is 10 112. This is okay. So we are done here. The next is we're going to define the load in this beam and this beam. Here is loading. So we have in beam 1, beam 2. When we use this kind of connection, so just we have to design in movements and shear of these two beam loading, not the column. So column movement doesn't has any effect, but it will has impact on the backlink of this column and the backlink of this connection. So first, this is beam 1. Beam 1, this is the axial force. So we are going to ignore the axial force, and we have kept Vy. If you see, this is if I go to, this is Y. So this is Y, and Z is up, Y is our side, and Z is this is Y, and this is X, and this is top is Z. So again, beam 1, we are going to give the right the right to the beam 1, that is Z in Z minus 85, which is in the top, but we are going to give up minus 85 kips. So it's minus 10 minus 10. Now we can see this is in the lower part, and the second is moment should be in a Y, that is about minus 23. This is foot by inch. We have to check, use foot inch, and then go here, check this beam, the shear force. This is moment shear, and this is shear should be moment shear should use V2, not V1. Yeah, because here, so we're using about 12 caps. 12 caps, we use 10, and this is 12 caps, and the moment should use moment 3 here. Already we have about 460 in y direction, called minus 465. So that's it. We have a top. So this is 2 moment, moment 3, and moment 3 is in a Z direction, which we call major moment. This is we got, and the second is to use a moment, this one, so it's about 10.8. We are going to select this one and going to here, beam 2, the same here is should be positive, so positive, yeah, 11, we can give it 11, so 11, and the moment should be 285 in negative, minus 285.5 negative. Yes, so we have both sides. The loading is completed. If we want to add the column load, that's also acceptable, but if we don't, that's okay, because the major column is loading is in the beam, so that's enough. Now we are going to connect this beam to this member. Here we can select which type of connection we want. The first, this is a moment resisting frame. I'm going to use this moment. We have a doubler plate here, and also 2 stiffener. Maybe this is very strong, but our wish is to in the first design iteration we should pass. If it's not economical, then we can reduce. So the bolt size is using size A23, then make a little larger, bigger size. So I'm going to use, yeah, I'm going to use this 30. Okay, Now here we go. So this is it, and the second I'm going to connect this member beam to again to this flange, and using the same with 30 plates. Okay, now we define a default connection um, for our project but I guess this is not economical because so this is very strong, but let's see. Loading is uh, loading is completed. We're going to run the analysis, calculate. Sorry, duplicate will found. Oh yeah, yes. Here is one things which duplicate. Uh, because we use both sides is same. This is uh, not appropriate. But if we should actually delete, or we should turn off. Uh, okay. And this will this. I'm going to delete all these operation. Going to delete this operation. Going to delete this operation. All of this operation. Going to use another type of, because in the in this region beam column joint it is double weld. So we try to use automatic method, but it didn't fail. We can go to check another type of connection that may can okay. Then again we are going to uh, connect to just this. We are going to use this method instead of that, or we can use another type of method. One, we are going to use this, and the second we are going to use yeah, this is okay with two stiffener. And the second, if we use this method, but there is also, but before I'm going to delete this stiffener, delete this stiffener here. Going to delete this stiffener, and this I'm going to again connect to here. In this time I'm going to allow the stiffener should apply. This is the stiffeners, and one more thing is I'm going to increase the bolt size. Going to this connection, here is the bolt. The bolt size should be here, or maybe I can go to delete this and go to again connect member to this here. This time I'm going to automatic, it will fit, but there is one thing, there is called the stiffener 2, so I'm going to delete the stiffener 2. Okay, now normally we have a sample connection with two stiffener, and if you wish to change about this is I'm going to use this method and increasing the uh, size of uh, weld, and also this is it. And the second, we are going to select this one and also select these two type of, and we can use a little or stronger weld. This is done, and the size of nut bolt is also done. So we're going to run this. What you can see, yeah, it's very nice, and all the analysis passed, which is weld is 75, very economical. The bolt is also, and plate is also. So the analysis completed for this project. Just we use this. So another part is also we can use this method. Now we are going to check some. Sorry. Okay. Now we are going to check some deformation. Which part will deform? Going to the check. We're going to check. This is X, and I'm going to equivalent this. So this is it. Plates. Here is the plate deformation here, and bolts are here, and also we can see the mesh shape and deform shape. So there is not too much deformation in the entire connection, and also plastic strain. So we all have in a very long capacity. So strain check. So this is least done, least very it's in the zero. So finally this is okay. We are going to check our report, and also we have capacity design, stiffness design, and another topic design. Yes, the report is completed. Now we can see our deformation, and also our bolt size, shape, data is status is okay, and the calculation, everything is okay. So the code we used, this is the steel code, and everything is done. So this was a very beginner example of how we can design a connection from a designed building. This is the procedure. And if you have a SAP 2000 like 17 or 20 version, then you can select this node, and also here in the tool IDEA StatiCa has a plugin. You can add that plugin and import the data to the IDEA StatiCa. So this is the end of our tutorial. Thank you for watching. If you have any question, please put in a comment. I will give time and answer your question. See you next time.